Hello, and welcome to Section 3, Dockerfile Deep Dive. In this section, we will break down the purpose and contents of a Dockerfile, learn what the commands mean, how to use them, and finally, we will write our own custom Dockerfile and then use that to build an image of our very own. In this video, we will learn what a Dockerfile is and what its purpose is. We will understand why they are important to Docker and why you must know how to read and write them. A Dockerfile is a blueprint for a Docker image. When we build a Dockerfile, the result is a Docker image that can then have instances created, which are called containers. At its core, a Dockerfile is pretty simple. You can think of it as a step-by-step guide on how to assemble your image, kind of like a recipe. It should contain every single step that you need to get your application running. Anything from installing dependencies, compiling your source code, declaring what ports your app will listen on, or setting the current working directory, or maybe even changing the user inside of your image. In a Dockerfile, most new commands create a layer, which is saved as a file, and the output of that command is hashed. An image is broken up into layers so that when you are creating new images, pushing images to a registry, or downloading images from a registry, Docker can quickly determine if those layers already exist on the target system by comparing hashes, and if the layer does exist, Docker does not have to build them, upload them, or download them. One of the features that makes Docker really powerful is its caching. Caching is when you store some data in an easily accessible manner so that future requests for the same data can be served faster, either by avoiding fetching from a slower data source or by preventing expensive computations. A cache hit is when the item you are looking for in the cache is found. A cache miss is when the item you are looking for in the cache is not found. In Docker, while building Dockerfiles, as soon as there is a cache miss, the cache is considered broken, and all subsequent layers must be rebuilt. Caching makes Docker actions much faster, and understanding how it works can greatly improve your Docker experience.